Okay, so today we're going to talk about two types of genetic drift. And what genetic drift is a mechanism by which random selection determines traits in genetic populations. It's completely random. There's no natural selection component to this. And there are two types of genetic drift. There is the founder effect, and there is also the bottleneck effect. And the bottleneck effect is what we're going to be demonstrating most accurately today with an actual bottleneck right there. So this happens in all populations, but it's most keenly seen in small populations because there's less genetic diversity to begin with. So again, genetic drift happens across all populations, all species, all over the world. So if you'll come right here for me, please. So we've got these two types of beads. We've got red traits and we've got orange traits in a population. The founder effect says that if you have a population like this, you might get some more oranges, you might get some more reds when they breed together. But if, say, these 5 reds go off on their own and form their own little colony of whatever species this is, bedosaurs, if the red bedosaurs form their own colony and they found a new area, you're going to get strictly red offspring, and over here you'll get strictly orange offspring. And you can see why this is more prevalent in smaller populations. So the second type, let's screw our top here. The second type of genetic drift is the bottleneck effect. Say all of these different types of beads here in the bottle represents the same species, but each different color and shape bead is a different trait in that species, okay? Say there's some type of extinction event, right? Population reduction event that happens and wipes out a huge segment of the population all at once, like what happened approximately 12,000 years ago, where over 70% of terrestrial mammals were wiped out. And cheetahs survived this, but just barely, so they had a really tiny population. So here's our cheetahs with all of our different bead traits, and here comes the genetic, or the extinction level event. See, we're crammed up in the bottleneck here. All these are dead. Bye-bye cheetahs, very sorry. And here is our new gene pool to select from. Not nearly as diverse as what we had to begin with. So after that bottlenecking event happens, we're left with a much smaller gene pool. And so when inbreeding occurs, you have less samples of diverse genes to draw from to make the new pool, and that's what leads to genetic defects in modern populations of cheetahs, even 12,000 years later. It takes a really long time for these things to sort themselves out, and if they don't sort themselves out, you don't get a diverse enough genetic pool, the species stands a chance of, unfortunately, going extinct.